Okay, in the next section we look at some examples that relates to exponential growth, and here we have a question. It says find the future value P of the amount 20,000 invested for a time period of 2 years at an interest rate of 3% compounded continuously. So this one actually isn't really calculus, it's just algebra. We just need to put in those values into the equation. So P equals 20,000 times E to the 0.03 times 2. So $20,000 invested originally for 2 years, and 3% we put in as 0.03. And you just do that and you're at your answer. So that's 20,000 times E to the 0.06. And we arrive at an answer of $21,236.73 if you round to the nearest penny, which you should. And that's the answer. So not too difficult. That 20,000, if compounded continuously at 3% for 2 years, increases in value to about 21,000. So you can see that that's about a 5% growth, a little bit more, maybe 5.5% growth from the original amount. Let's try doing one with some actual calculus in it. This one says the capitalized cost of an asset over its lifetime is the total of the initial cost and the present value of all maintenance that will occur in the future. They give us a nice little formula that I put right here for calculating it. And so this is how this relates to how you might account for something. And so you buy a product or a part and you need to fix it, and you lose value not just with the money fixing it, but with the opportunity cost of what you could have spent with that money. That's why we have to have an integral to represent the growing stuff you could have been spending that money on. It also relates to accounting with how you might have depreciation for a good and how it might affect your taxes. In any case, for our purposes, all we need to know are what these numbers are, which they tell us, and we can go ahead and calculate the cost, the capitalized cost, by just plugging the values into the formula. So let's do that. C is equal to 300,000 plus the integral from 0 to 25. The lifetime of the thing is 25 years. Our function is just 20,000. Remember that a function can be a number, a constant, so that's okay. E to the negative 0.05 t. And we're going to take the derivative of that with respect to t. So that's all we have to calculate right there. That's everything. Unfortunately, the integral is fairly easy to calculate. This just stays, that's not the case for all integrals. This just stays 300,000 on the outside. And what we need to remember is that when we take the derivative of this, we get the derivative of e to the t, which is e to the t, but then we have to do the chain rule, so we have to take the derivative of the power. The derivative of this power would be negative 0.05, because the t would become just a 1. So here's the long and short of it. Here would be the final answer. Take a look at that and see if you can understand why that would be the integral. It's because if we take the derivative of this, everything I just said comes true. This stays the same, but the negative 0.05 comes out. That would then cancel with the negative 0.05 here, and we would just end up with this result that we have right here. So fairly straightforward integral. This will be 300,000. This will be minus, let's do 20,000 divided by 0.05, which will be 400,000, so the amount actually goes up. Okay, so 300,000 minus 400,000, and that's going to be e to the negative 0.05 evaluated from 25 to 0. So we're not going to get a negative number because when we put in 25, oops, I left off my t. When we put 25 in for t right there, remember this e is in the denominator, so it's going to shrink this second number. So here we go. This is going to be C equals 300,000 minus, I'm going to do 0.05 times 25, which is 1.25. So it's 400,000 divided by e to the 1.25. All right, in fact, I should put this in parentheses because we're evaluating it. So all I did was I put in 25 there and moved it to the denominator to make the power positive. Now here's where you can't just put minus 0. This will be minus 400,000 divided by e to the 0, which we know is equal to 1. So that's going to be our total cost. All right, so this is where we actually can't just put minus 0, because when you put in a 0 in, you get e to the 0, which is 1. Going to cram all that into my calculator now. So 300,000 minus parenthesis 400,000 divided by e to the 1.25 minus 400,000, because this e to the 0 just is 1. When I do that, I arrive at an answer of 585,398. And in this problem, they wanted us to round to the nearest dollar, so I'll just leave it at that, but that is the correct answer. You could take it to the penny if you want, but I think it said round it to the nearest dollar. So you can see that this is a very expensive piece, probably something to do with property, and we could calculate the capitalized cost by just doing the integral. That's it on these examples. If you have a question, please email me, and we'll do another example in the next video.